Today we're diving into the fascinating world of Newton's disk, a simple yet powerful science experiment that reveals the secrets of color and light. This spinning disk, named after the famous scientist Isaac Newton, demonstrates how different colors blend together to create white light. In this video we'll explore the history, the science behind it, and even how you can make your own Newton's disk at home. Let's get started and see how spinning colors can teach us about the nature of light. Before we jump into the experiment, let's briefly talk about Isaac Newton. He was a brilliant scientist and mathematician who lived in the 17th century. Newton made groundbreaking discoveries in physics, mathematics, and optics. One of his most famous contributions was the study of light and color, which led to the creation of Newton's disk. Understanding his work helps us appreciate why this simple disk is so important in science education. Newton discovered that white light is actually made up of many different colors. When sunlight passes through a prism, it splits into a rainbow of colors. This phenomenon is called dispersion. Newton's disk is a clever way to reverse this process. By spinning the disk, the colors blend back together and we see white light. This experiment visually demonstrates the composition of white light in a fun and interactive way. Newton's disk is a circular disk divided into segments, each painted with one of the 7 colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. When the disk is spun quickly, the colors blend together and the human eye perceives the disk as white or nearly white. This simple device is a powerful demonstration of how our eyes and brain process color and light. Make your own Newton's disk. You'll need a few simple materials: a piece of sturdy cardboard or thick paper, colored markers or paints in red, orange, yellow, green, blue, indigo, and violet, a pencil or a small stick to act as the spindle, and some glue or tape. These everyday items are all you need to recreate this classic science experiment at home or in the classroom. Start by drawing a perfect circle on your cardboard or thick paper. You can use a compass or trace around a round object like a cup or lid. The size of the disk can vary, but a diameter of about 10 to 15 centimeters works well. Once you have your circle, carefully cut it out. This will be the base for your Newton's disk. Next, use a ruler to divide your circle into 7 equal segments, just like slicing a pizza. Each segment will represent one color of the rainbow. You can lightly draw the lines with a pencil first to make sure the sections are even. This step is important for ensuring that the colors blend properly when the disk spins. Now color each segment with one of the 7 rainbow colors: red, orange, yellow, green, blue, indigo, and violet. Use bright, bold colors for the best effect. Make sure to fill in each section completely so that the colors are vivid and clear. This step brings your Newton's disk to life and sets the stage for the magic to happen. To make your disk spin, you'll need to attach a spindle. Poke a small hole in the center of the disk and insert a pencil, stick, or even a skewer. Secure it with glue or tape so the disk stays in place while spinning. The spindle should be straight and sturdy to allow smooth, fast rotation. Hold the spindle between your fingers and give it a quick spin. As the disk rotates, you'll notice something amazing. The individual colors begin to blur together and the disk appears white or nearly white. This is the core of Newton's experiment, showing how our eyes blend rapidly moving colors into a single shade. When the disk spins, the colors move so fast that your eyes can't distinguish them separately. Instead, your brain averages the colors and the result is white or a light gray. This is a great example of how human vision and perception work, and it's the same principle behind movies and animations, where fast-moving images blend into smooth motion. Newton's disk demonstrates additive color mixing, where different colors of light combine to form new colors. When all the colors of the rainbow are mixed together in the right proportions, they create white light. This is different from mixing paints, which is called subtractive color mixing. Newton's disk helps us understand the difference between these two types of color mixing. Principles behind Newton's disk are used in many real-world technologies. For example, computer and television screens use tiny red, green, and blue lights that blend together to create all the colors we see. Understanding how colors mix helps engineers and designers create vibrant, realistic images in digital displays. Before inventing the disk, Newton used a glass prism to split sunlight into a spectrum of colors. This experiment proved that white light is made up of many colors. Newton's disk is a creative way to show the reverse, combining colors to make white. Both experiments are fundamental to our understanding of light and color. Newton chose 7 colors for his disk to match the 7 notes in a musical scale. The colors are red, orange, yellow, green, blue, indigo, and violet. While the actual spectrum is continuous, dividing it into 7 parts makes it easier to study and demonstrate. This choice also helped popularize the idea of the rainbow having 7 distinct colors. While Newton's disk is a great demonstration, it's not perfect. Sometimes the disk may appear grayish instead of pure white, depending on the colors used and the speed of spinning. The quality of the materials and lighting conditions can also affect the results. Still, it's a powerful and accessible way to visualize the science of color. You can experiment with different versions of Newton's disk. Try using more or fewer colors or arrange the colors in a different order. You can also use different materials like plastic or wood for the disk. Each variation can produce slightly different effects and help you learn more about how color mixing works. Teachers and students around the world use Newton's disk to learn about light and color. It's a hands-on experiment that makes abstract concepts more concrete. By building and spinning the disk, students can see the science in action and develop a deeper understanding of how our eyes and brains perceive color. The speed at which you spin the disc affects how well the colors blend. If you spin it too slowly, you'll still see the individual colors. The faster you spin, the more the colors merge into white. This is a great way to experiment with perception and see how motion changes what we see. Newton's disc isn't the only device that demonstrates color mixing. There are other tools like color wheels and spinning tops that show similar effects. These devices help us explore the fascinating world of color theory and understand how artists and scientists use color in their work. Our eyes and brains work together to interpret the world around us. When colors move quickly, our brains blend them into a single color. This is called persistence of vision, and it's the same principle that makes movies and animations possible. Newton's disc is a simple way to experience this phenomenon firsthand. Did you know that Newton's disc has inspired many toys and educational tools? Spinning tops with colored patterns, optical illusions, and even some art installations are based on the same principles. This simple experiment has had a big impact on both science and culture, showing how curiosity can lead to amazing discoveries. When making a Newton's disc, some common mistakes can affect the results. For example, using dull or uneven colors, not dividing the segments equally, or spinning the disc too slowly. Paying attention to these details will help you get the best possible outcome and see the white light effect clearly. You can also experiment with different color combinations to see what happens. Try using only primary colors or mix in black or white segments. Each variation will produce a different effect, helping you learn more about how colors interact and how our eyes perceive them. Artists have long been fascinated by color and light. Newton's discoveries influenced painters and designers who use color theory to create stunning visual effects. By understanding how colors mix, artists can make their work more vibrant and lifelike. Newton's disc is a bridge between science and art. For an advanced project, you can use a small electric motor to spin your Newton's disc. This allows for faster and more consistent spinning, making the white light effect even clearer. Motorized versions are great for classroom demonstrations and science fairs, showing the principles in a dramatic way. Isaac Newton's work changed the way we understand the world. His experiments with light and color laid the foundation for modern physics and optics. Newton's disc is just one example of his genius, showing how simple experiments can reveal deep truths about nature. Let's recap what we've learned. Newton's disc is a simple device that demonstrates how white light is made up of many colors. By spinning the disc, the colors blend together, showing the principles of additive color mixing and visual perception. This experiment connects science, art, and technology in a fun and engaging way. Science is all about curiosity and exploration. Try making your own Newton's disc, experiment with different colors and speeds, and see what you discover. Every experiment is a chance to learn something new and appreciate the wonders of the world around us. Thank you for joining us on this colorful journey into the science of Newton's disc. We hope you enjoyed learning about light, color, and perception. Keep exploring, keep asking questions, and remember, science is everywhere waiting to be discovered. See you next time.